Hello students, we have already discussed the syllabus of class 12 physics. Now we are going to start with the syllabus of class 12. Before starting the syllabus, let me tell you some of the things. First, the syllabus I have already given you that must be noted down in your notebook properly, because this is going to help you how many topics we have covered and how many topics we have left, and keep underlining the topics we are going to discuss so that we should be aware how much syllabus we are going to do on daily basis. And second thing, follow your NCERT strictly. If you have, well and good, you can download it online also, and if you don't have, I will download it and I will send it in the group. And one very important thing before starting it, you must fix your target for CBSE exam according to your capability, not according to your capability, rather you should fix a little bit higher targets and you are supposed to achieve that target. And daily basis target you are supposed to fix, and don't fix a yearly target. Yearly target, you will skip your studies for 1 month or 2 months. Don't skip even a single day. So daily basis target, what topic you are supposed to do and which subject you are going to do on daily basis, this target you have to fix, and keep checking your targets whether you are able to do it or you are just wasting the time. So stop wasting time. Whatever the mistakes we have committed in class 11, we are going to leave all the mistakes from here, and we are going to now start the syllabus of 12th, and we are promising to ourselves only that we will get very good marks in class 12th. So before this, I would suggest you to write the target on your notebooks, and after that, notebooks, you can use old notebooks, as I have already told you. The same notebooks subject wise you are supposed to maintain, and write the syllabus properly. I'll send the PDF file of your syllabus also. Write it properly, and proper unit wise, and what are the contents unit wise, everything you are supposed to write in your notebook. So let us start with the first unit of the syllabus, that is electrostatics. As I have already told you, electrostatics consists of two parts. One is electro and second is the statics. Electro here is regarding charge, and statics means at rest. So in this particular unit, we are going to discuss various properties of the charges, and charges which are at rest. So when the charges are at rest, so what are the different and various properties related to those, we are going to discuss here. And this unit of electrostatics consists of two chapters of your NCERT. First chapter is electric charges and fields. So we will start with this. Electric charges and fields, and you see, as per the syllabus, what are the different contents are there in this particular topic. Let me tell you. I'll send this file also. Please do write all the contents. First is electric charges, conservation of charges, Coulombs Law, that is a force between the charges. So first, very important thing before going to this particular chapter, let us discuss what charge is. Charge is the intrinsic property of any object. We know that you might have already having this idea of what charge is, what you will say. This is a charge, this is a property an electron is having, this is a property a proton is having, this is a property an atom is having. We know that in a particular neutral atom, number of the electrons and protons, they are equal. So that is neutral, no charge is there. Why no charge is there? Because equal negative and equal positive, they are going to cancel each other. Now, when a body is going to have the charge, charge is intrinsic property of a body which is able to attract or repel another body having the same property. So, charge is the intrinsic property of any object. As mass is the intrinsic property, charge is also the intrinsic property. Now, what symbol we can use to represent charge? Symbol capital Q or small q with plus minus. Positive charge, plus can be used, negative charge, minus can be used. So these are symbols for representing charge. What are the units of the charges? Various units are there for the charge, but SI unit we are going to discuss. What is SI unit for the charge? That is Coulomb. Capital C. This we would be using for the numericals and for representing the charges. So this is all about charge and its units. Now let us discuss the various properties of the charges. First property, types of charges. How many types of charges are there? Two types, one is positive, one is negative. So first property is regarding the types of the charges. So here we are discussing the properties. First property is types of charges. For one type is positive charge and another is negative. Two types of charges, we know that. And second property, charge is a scalar quantity. As we know that charge is not having any particular direction, it is having only magnitude, so it is a scalar quantity. Third property, we know that if a body is having the charge, it can attract or repel. So this is also the property of the charges. Like charges, they will repel. And unlike charges, attracts. So two negative charges, they will repel each other. Two positive charges, they will repel each other. One positive, one negative charge, they will attract each other. Fourth property is charge is additive in nature. What does it mean? Additive nature, we can simply add the charges using simple algebra. For example, one body is having charge plus 5 coulomb, another body is having charge plus 5 coulomb, and one third body is there which is having the charge 3 coulomb. So net charge would become, simply use the algebra, what charge would it be, become? 5 plus 5 minus 3, that is 7 coulomb. So this is the additive nature. Suppose if I say first I have given 5 coulomb, then I have given 3 coulomb, total charge on the body is simply 8 coulomb. We are not supposed to apply any other vector rule or some other rule. Simple algebra we can apply to add the different charges. Next property is very important property, that is the quantization of the charge. Quantization of charge. This is a different property, and what does it mean? Quantization. What is the meaning of quantization? Quantization means when if I say if something is given in fixed amounts. For example, if I say a body has some charge, if a body is having negative charge, it means it is going to have excess of the electrons, because the body can be charged by transfer of the electrons. And you see, when body is going to gain the electrons, it will acquire negative charge, and the body which is going to lose the electrons, it will acquire positive charge. And you see, electron as a whole can be transferred from one body to the other body. We cannot say that half of the electron is going to get transferred or 0.25 of the electron is going to get transferred. We can't say this thing. As this marker, you can buy 1 marker, 2 marker, 3 markers. You cannot buy 2.5 markers. You cannot buy 2.25 markers. So some of the objects can be given in fixed amounts. So the same thing is here. If a body is having the charge, it would always be the integral multiple of the electronic charge, because the body is going to acquire the charge because of the transfer of the electrons. So in other words, we know that the minimum charge on the object can have electronic charge. The electron, we can say this is the smallest independent physical object which can have the minimum charge. Independently it can exist, and this is the minimum charge in the universe that can exist independently. I am talking about independent word here, quarks. You might be knowing the concept of the quarks. Quarks, they have the charge which is 1/3 of the electronic charge, or they may have the charge which is 2/3 electronic charge. So this is they have the charge which is smaller than the electronic charge, but even then we will say that this is not the minimum charge which can exist independently. Independently, why? Because they are not independent physical quantities or objects. They always are there in the elementary particles in bound state. If I'm talking about proton, it is having 3 quarks. These quarks are up quark and down quark. And you see, all these 3 quarks, they are bound together very strongly inside the proton. We cannot separate them. Independent quarks cannot exist as per latest rules. So the independent minimum charge which can exist, that is the electronic charge. So that is why we can say that if a body is having charge, suppose Q, and if I am saying that a body is having charge because it has gained 1 electron, then how much charge it has acquired? 1 electronic charge. And electronic charge is what? Charge of the electron, we know that it is 1.6 into 10 raised to power minus 19 coulombs. This is a minimum charge which can exist independently. So if a body is going to acquire 1 electron, it will have minus 1 electronic charge. If a body is going to have 2 electrons, then how much charge it is going to get? That is 2 electronic charge. Similarly, 5 electrons a body is going to gain. It will acquire the charge of the 5 electrons only, and so on. Similarly, the body which is going to lose the electrons, 1 electron if it has lost, then what charge it would acquire? It would be plus E, positive charge, and the 2 electrons it has lost 2E, 5E, 10E, and so on. Or in other words, what we can say that a charge on any object or body can be the integral multiple of the electronic charge. E here is the charge of 1 electron, and here is the number of the electrons which have been transferred from one body to the other body. So n can be any integer. Very important thing, this is an integer. So this principle is the quantization of the charge. So charge on any object is quantized. And one more property is there, that is conservation of charge. Conservation of charge. Conservation of energy, as we know that total energy of the universe is constant, or any isolated system is constant. So similarly, the total charge of an isolated system is conserved. So you can write total charge of an isolated system is conserved. For example, I am having this as isolated system. I am drawing here. Let us consider this is an isolated system, and for example, it is having 3 objects. It is having 2 electronic charge plus 2E. It is having plus 3 electronic charge, and this is having minus 5 electronic charge. So we can say that the total charge of this isolated system is 2 plus 3, 5 minus 5, that is 0. So this isolated system is neutral. For example, By friction, by conduction or induction, we will discuss later how the charge can be given to any object. For example, one of the electron is going to get transferred from one body to the another body. This is having excess of the electrons. Let us consider that it is losing one of the electrons. So this body will acquire plus 4e and one electron is going to get added here. Let us consider minus e is going to get added here. So this body will acquire the charge, that is 3 electronic charge minus 1 electronic charge, that is 2 electronic charge. Now you can see 2 plus 2 4 and minus 4 again 0. So you see total charge of an isolated system will remain conserved. So this is all about the conservation of charge. Now because you see one very important property about numericals we have discussed, this is the quantization of the charge. So for this property, let us discuss what type of numericals can be asked and what type of questions can be asked. The questions they can be asked in the exam, that is regarding this n, means quantization of charge will always be valid. And you see, if I am asking one question, for example, regarding this, I am asking one numerical here. Let us consider the charge. For example, charge given is, charge on any object is 6.4 into 10 raised to power minus 18 coulomb. For example, this is a charge of any object. And suppose if I am asking, is this charge possible on any object? Now what we want to check, is this charge possible or not? Now we have to apply this principle, that is quantization of the charge. So this formula I am going to apply here and I have to simply check whether n is an integer or not. So Q is what? Q is 6.4 into 10 raised to power minus 18 coulomb. And E is what? E is electronic charge, that is 1.6 into 10 raised to power minus 19. Simply find this n. What is the value of n here? So n will be Q over E. That is 6.4 into 10 raised to power minus 18 divided by 1.6 into 10 raised to power minus 19. So what we are going to get here? 4. And this will go here and what you will get here? 10. So 40 electrons. So you see this 40 is an integer. So it means 40 electrons, when the transfer of the 40 electrons is able to give this amount of the charge. So this is possible. If suppose, if n value you are getting 39.5 or 39.7, suppose you are not getting any integer, then this would not be possible. This charge is not possible. So if we are getting this integral value, then only this charge is possible. And if any point or fraction we are getting, then we will simply write this charge is not possible, because the number of electrons can be they can have any integral value. So 40 electrons, okay, what does it mean? 40 electrons means if a body is going to be given this charge 6.4 into 10 raised to minus 18 coulomb, and you see if no sign is there, it means it is plus. So how we can give this charge to a body? We have to simply take 40 electrons of that body, and then the body will acquire this amount of the force or charge, sorry. So this type of numericals or conceptual questions can be asked. Now we are talking about the body is charged. Now let us see how we can give charge to an object. Methods of charging any object or any body. Okay, there are two methods we will discuss here. One method is conduction. Conduction means when the electrons are going from one body to the other body, actually they are moving inside the two bodies, and you see one electrons are going to go to the another body by conduction method only when the two bodies are in contact. So here one condition is there, the two bodies when they are in contact, charge from one body can go to the other body. So the main condition is both of the bodies are in contact, only then the charges can flow from one body to the other body. Charges can flow means here the free electrons of the body can flow from one body to the other body, and you see because of the movement of the electrons, the two bodies will acquire the charges. One body is already charged, and if suppose other body is uncharged, for example, let us consider I am having this sphere, metallic sphere for example, and suppose it is having some charge plus 10 coulomb. And let us consider another body is there, and same type of body is there, and this is having no charge. Now you see when both of these spheres they are in contact, initially this is having charge plus 10 coulomb and this is having 0 coulomb of charge, means it is neutral. Now what would happen? Here deficiency of electrons are there, and here number of electrons are full. So what would happen here? Excess electrons of this body, they will get attracted towards the deficiency of the electrons, and the electrons will start moving towards this side, and they are leaving behind the positive charges. Here you see electrons will keep moving inside towards this side till the equilibrium is set up. So finally what would happen? The total charge on both of the bodies will get uniformly distributed. Uniformly word we are going to use here when both of the bodies have the same size, same dimensions and same material. In NCERT you will see some of the numericals, identical spheres is used. Identical means here their sizes, their dimensions or their materials, they are same. Okay. Now you see in the when identical spheres are going to get in contact with each other, then one charged body will charge the other body and the charges would be uniformly distributed, means after the equilibrium is set up, both of the spheres will get same charge, that is 5 coulomb. So this is one of the method by which you can charge another body. Okay. In lower classes, one very important example we have already discussed, means when we comb our dry hair with the comb, then comb is able to attract the pieces of the paper. Frictional electricity is a part of this, means we are giving the contact, your comb is in contact with your dry hair, then it is going to get the charge. Okay. And you see why they are going to get the charge. Another example we can consider, for example, I am having one glass rod, and for example when some silk cloth is rubbed with this, then also both of the bodies, when after rubbing, both of the bodies will acquire charges. This will become positively charged and silk will become negatively charged. Why this is there? Again because of the transfer of the electrons is taking place. So that is why both of the objects, they will acquire the charge. So this is how we are going to give the charge, how we are charging the body by the contact of the two bodies, or this method is called conduction. And here you see electrons are moving from one body to the other body and the bodies are going to get charged. Another method of charging the objects is induction method. Induction means here no contact would be there in the two bodies. One very important thing, no contact. There is no contact between the objects. Then how the charges can be given to the body? For example, now you see, if there is one sphere, metallic sphere, which is insulated from the earth, no charge is there. Now let us consider I am bringing a rod near this which is charged. Now what would happen? Because this positive charge will attract the negative electrons. If it is conductor, we know that it would be having maximum abundance of the free electrons. So this positive charge would be attracting the electrons of this sphere. So all the electrons will start accumulated towards this side, leaving behind the positive charges. So you see here charges, overall charge on this object is 0, still 0, it is neutral. Now how we can give the charge? For example, if I am earthing this side of the conductor, what would happen? This positive charge will get neutralized, that will go to the earth, and what would happen after that? If I am removing this earth and we are removing this, you see, when we are giving the earth to this side, this is still there, this rod is still there, so that the negative electrons stay towards this side. And after removing the positive charges from here, we are going to remove this earthing also. And now you see, excess of the electrons are there. Now the sphere is not neutral. And you see, when you're going to remove this rod also, what would happen? This negative charge will be uniformly distributed on the sphere. And this would be uniformly distributed on the sphere. Now you can see here, I have not touched this rod with this sphere, but even then the sphere has got some charge. No contact was there. So this is by induction. You see, when we are bringing the positive rod near this sphere, then the charges have been induced inside the sphere. So this is one of the method by which we can charge one uncharged object. And similarly, if we are bringing a negative rod, then what would happen? This negative rod will attract the positive charges, or in other words, we can say this will repel the free electrons of the sphere towards the other side. The same method. So electron will be repelled to this side and leaving behind the positive charges, and again keeping the rod here, we can earth these negative charges, and then after removing these charges from the sphere, this is not remaining neutral now. Now when you will remove this rod, this sphere will get positive charge, uniform positive charge all over the sphere. So this is another method, second method, that is the induction method by which we can charge the body. So these are the two different methods by which we can charge the bodies. Now let us discuss one very important concept of this chapter, that is the Coulombs law of force. Coulombs law. We have discussed that the like charges, they will repel each other, and unlike charges, they will attract each other. By how much magnitude and in which direction? So repulsion and attraction, that will give you the direction. But what would be the magnitude of the force between two charges, whether they are like charges or unlike charges? This law will give us the magnitude as well as direction, also in vector form will write. So magnitude of the force, how much magnitude is there between the two charges, magnitude of the force is there between the two charges, that we can calculate using this law, Coulombs law. So this law states that, for example, I am having two charges, one is Q1 and another is Q2. Now consider these two charges are separated by some distance r. Then according to Coulombs law, force between the two charges is directly proportional to the product of the two charges, that is Q1 and Q2, and it is inversely proportional to the distance between, square of the distance between the two charges, that is 1 over r square. If you will combine both of the statements, so we can write F is directly proportional to Q1 Q2 over r square. So this proportionality is there, we have to remove that proportionality. For removing that proportionality, we have to use one proportionality constant. So I'm going to use the constant K here. K times Q1, Q2 over R square. What is this K? This is the constant of proportionality and its value is 9 into 10 raised to power 9. So now let us write down the units of this constant also. What would be the unit of this constant K? It would be Newton, then meter square per Coulomb square. So along with the units we have written the value of this K. For numerical purposes we can simply use this value of the K, that is 9 into 10 raised to power 9 Newton meter square per Coulomb square. What is the exact value of this K? Now let me explain. K is 1 over 4 pi epsilon naught. Now you see what this epsilon naught is there. Epsilon naught is the permittivity of the vacuum, absolute permittivity of the vacuum. Let me explain this epsilon naught here. Epsilon naught is the permittivity, absolute permittivity of free space or vacuum we can write. So what is this permittivity? This is the property of the medium or vacuum which tells us about the electronic properties of the medium. Now suppose if we are writing, suppose this is the force when the two charges are placed in the vacuum. In that case we have to use this epsilon naught word and its value is, for vacuum it is 8.854 into 10 raised to power minus 12. What would be the units of this? You see it is inversely proportional to K, so units would be inverse. That would be Coulomb square per meter square per Newton. So these are the units